Let's take a look at rounding decimals, which is basically the same as rounding whole numbers, except for one key difference having to do with the zeros. With that, you need to remember the term significant digits. I'll discuss that, what that means. So if we round these first set of numbers to the nearest tenths place, that's right here, that's the tenths. That's your significant digit. That means that anything that follows the tenths, we don't even want. We're going to have those get rid of. Okay? So let's take a look at how that looks. So our first number is 9 and 63/100. I'll do the first one on here, 9 and 63/100. Like we said, there's our significant digit. Anything after it. We do need to know those digits though, because we have a 6 here, but we have a 3 here. So when we're using our rounding rules, 3 is going to remind us to keep that 6/10 as a 6. Everything else, if you kind of think of it like a little hill, here's a wall. This would normally turn into a 0, which kind of rolls away. So this becomes 9 and 6/10. Let me show you how to do it without the place value chart. So if I have 8,478 10,000ths, well, again, if I'm rounding to the nearest tenths place, well, I'm just going to kind of construct a little wall here. That 4 is going to tell me what to do. The 4 tells the 8 to round up. So this is going to become 0.9 or 9/10 because these are going to just roll away. Now our next one is a little different. Our next one, 9 and 3 and 972 thousandths. Well, there's that tenths place. Okay, so here we are looking. Okay, well, what's the 7 tell the 9? Well, the 7 tells the 9 to round up, which means it goes to 10, which we can't fit. So it's that rolling 9 idea, right? So we're going to go to bring that up here, so it becomes 4.0. Now remember, we have that wall there. So that 0 is going to stay. It is a significant digit. We have to have the tenths place. So the answer to this one is 4 and 0/10. If you see the word tenths, you must see the digit tenths, even if it's a 0. Let's take a look at another one. Now we're going to go to the hundredths place. Now when we're talking about the hundredths place, our significant digit moves out one more place. We must have these two digits. So 1 and 353 thousandths. Well, there's the hundredths place. The 3 tells the 5 to stay. So we have 1 and 35 hundredths, and then those go away. 12 and 5,723 10,000ths. The 7, the 2 is going to tell the 7 to stay the same. So it's 12 and 57 hundredths. These roll away. Now, my last example is we're going to go to the thousandths place. Well, if we're thinking significant digits, now we need to have all 3 of these. We need to have tenths, hundredths, and thousandths. So let's take a look how that's going to work. 2,891 10,000ths. All right, well, there's my thousandths place. That 1's going to tell the 9 to stay the same, so it's 289 thousandths. Now I have 38,996 hundred-thousandths. So I need to look for my thousands place. Kind of do that. That's there. This 9 is going to tell that 9 to round up. It becomes a 10. So I do that rolling 9. That 8 becomes a 9. And then I keep my 3. These 2 digits are going to go, but I have that 0 because it's a significant digit. So my answer in this case is 390 thousandths.